All right, and welcome to the third video in my classes video series for Unit 1. We have spent some time talking about the different classifications of matter, right? Those four different categories that you can sort substances into. We've also spent some time talking about the different states of matter. Each substance, each bit of matter is going to be in a particular state, right? Solid, liquid, or gas. Today, we are going to get into some of the other physical and chemical properties that matter can have. And we're also going to introduce ourselves to physical and chemical changes that matter can undergo. All right. And once again, this is a little bit of sort of like an introductory lesson. We're not going to talk about all the different physical and chemical properties and all the different physical and chemical changes that can happen, but we're going to sort of learn what this is all about. And actually, I really should come to this slide that has the specific outcome or objective for today's lesson. So what you're going to be able to do at the end of the day today is we're going to be able to distinguish between physical and chemical properties and then be able to distinguish between physical and chemical changes. Okay? And we're going to go through all of this. I have a nice little graphic organizer for you if you are following along at home and taking notes perhaps. If you have a printer at your house, then you can just click on this link. You can print out this little table and you can fill it in as we go. If you don't have a printer at your house, that is totally okay. Whatever you're taking notes on, you can just make a table similar to this. It should take up about 1 page in size, and that way you'll have enough space to write things down as we encounter them. Okay, so let me go ahead and make this full screen again. Okay, so in the first couple of boxes in that graphic organizer, there's something I want you to write down, which is true about physical and chemical properties and changes in general, okay? So in general, physical properties and physical changes, in both of those situations, in a physical type of thing, the identity of the substance doesn't change, okay? And in the case of properties, whenever we're talking about a physical property, we're not talking about how the substance can change. Okay? On the flip side, with chemical things, we are talking about situations in which the identity of the substance can change. Okay, so like for a chemical property, we're going to be describing how the substance can change. And then in a chemical change, the identity of the substance does actually change. Okay, and this is going to make a little bit more sense as we get into the notes. But this is sort of the fundamental difference between physical and chemical aspects of matter, whether or not the identity of the substance is or is not changing. Okay, so let's talk about properties in general. Okay, so in general, and by the way, if you're following along on that graphic organizer, this is going to go underneath the word properties on the far left-hand side of your screen, or of your paper. So properties, what are properties? Properties are traits, characteristics, or descriptions, okay? Think of adjectives, all right? Here are a couple of examples. Lead is a soft metal. Okay, and that's actually true. So if you look over here at this little picture here that I snagged off of Wikipedia, this is a picture of a lead pipe that was actually built and used by like the ancient Romans, right, like 2,000 years ago. The reason that lead was used in piping, dating all the way back to 2,000 years ago, was because it was soft and malleable. Okay, that's another little word there for you, malleable. It was easy to change its shape. So you could fit it into places and form it into places that a more rigid metal might not go. Also, if the earth ever moved, right, so if there was like an earthquake or something, or, well, maybe not an earthquake, but the earth can shift, from time to time. And so if the earth moved a bit, the lead pipe would adapt to the new shape relatively easily, whereas a more rigid metal might snap, right? And then your pipe doesn't work anymore. So, in fact, we get the word plumbing, 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 we get that from the Latin word for lead, which is plumbum, okay? And actually, the symbol for lead on the periodic table is Pb. It comes from the Latin name for lead, which is plumbum. Another example of a property, okay, so not necessarily a physical or a chemical property, but just properties in general, is that fluorine is very reactive. Okay, and that is definitely true. Fluorine is one of the most reactive elements in our universe. There is a acid called hydrofluoric acid, which contains fluorine, and it's very, very dangerous. You have to go through some very, very strict training to learn how to handle hydrofluoric acid, because if there ever is an accident with hydrofluoric acid, some very bad things can happen. This person's hand, looks like their index finger and then definitely part of their middle finger here as well, has been exposed to hydrofluoric acid. And this, trust me, this probably hurts a lot more than it looks. This is not the same sort of thing that happens when you go to the pool. You know how if you're at like the pool for too long, your water or your hands can kind of shrivel up a little bit due to the water. This is a little bit different. So the fluorine in the hydrofluoric acid is actually reacting with his skin and his tissue to such an extent that this is probably all eventually going to like peel off. I'm sure his skin his outer layer there is dead, and this is going to look a whole lot worse probably in a few days and weeks from now. Okay, so that's properties in general. Now let's talk about physical properties. Okay, so you're going to move one square over, sort of where properties and physical line up. Physical properties of substances are the inherent properties of substances. Okay, these are things that may be observable with your five senses. So things like the color of something, or its texture, its hardness, how much it weighs, its density, even its state, for example. So if it's a solid or a liquid or a gas. Inherent just means things that are just that you can't take away. Okay, that's kind of what inherent means. So physical properties, like I said, any of these things here, mostly observable with your five senses. One other big physical property that I need you to know is melting and boiling points. Okay, so the temperature at which a substance transitions between states. So for example, with water melts at 32 degrees Fahrenheit or 0 degrees Celsius, and it boils at 212 degrees Fahrenheit or 100 degrees Celsius. Those two numbers, the actual boiling point, those two numbers are physical properties of water or of a substance. Okay? So remember, physical properties don't ever talk about how the identity of a substance is changing. Whenever water goes from being a solid to a liquid to a gas or vice versa, the identity of the water is not changing. Okay? That's why this is a physical property and not a chemical property. It's still water. It's still H2O. Okay? It's not changing into a different substance. All right? Now, that is not the case when we talk about chemical properties. Okay? So chemical properties describe how a substance can interact with other substances or how a substance can change into another substance. So these chemical properties are a little bit harder to spot sometimes. So here are some keywords that you might want to look for. A compound's reactivity or a chemical's reactivity, its flammability, its toxicity. These are all these would all be chemical properties of substances if you hear them discussed. Okay? But once again, chemical things in nature tend to talk about how the identity of a substance changes. Okay, so let's talk about changes then. So we just got done talking about properties, so now let's talk about changes. Changes, and once again, this is going to go sort of on the left side of your paper there. Changes are actions or scenarios. So instead of adjectives, I want you to think about verbs. Okay? So here's some examples. The lake froze overnight. Okay? Or a pond. So that's the action of liquid water turning into solid water, right, due to a cold overnight. It might also be something like this. Your car burns gasoline. Okay, so the gasoline is getting burned and it's changing into something else. Okay, and once again, what I'm mentioning here are just changes in general. Okay, so I'm not talking about physical or chemical specifically yet. These are just changes in general. Okay, so let's talk about them specifically. Physical changes. All right, so physical changes, these are just changes to a substance that affect its shape or form. Okay, so like if you crush something up, or if you bend it, or if you break it, okay, like breaking a pencil, or bending a lead pipe, right, or crushing a graham cracker into pie crust. Those would all be physical changes. And then once again, I did mention this before on the previous slide where I talked about physical properties. Any of these changes in state are just physical changes. The identity of the substance doesn't change when its state changes, right? It's just the behavior of the particles that change, right? But the identity of the substance, what it actually is, that does not change in these processes. Okay, so I need you to know that. All right, and then we get to the fun one here, chemical changes. Okay, chemical changes are synonymous with the term chemical reactions. Okay, so a chemical change is a chemical reaction. All right, I'll refer to it as chemical changes for now, but later on in the semester, maybe towards the spring even, we're going to get into talking about chemical reactions in lots of detail, in which a lot of the stuff that I mentioned here is going to be familiar to you. In a chemical change, okay, or a chemical reaction, a new substance is formed, okay, 100% of the time. If a new substance has not been formed, then it isn't a chemical change. Okay, and let me just back things up real quick. In all of these scenarios that I gave you, a new substance is not being formed, okay? Even if you crush a graham cracker into pie crust, it's still the graham cracker, right? It's not some magical new substance, right? So in order for something to be a chemical change, you have to have a new substance that is formed, and that's why it's a chemical reaction, okay? So here are some of the things that you can use to justify whether or not you think something is a chemical change or not, okay? If you see a change in color, okay, usually this means that a chemical change has taken place. This is not 100% of the time, it's just a general rule of thumb. If the smell of something changes, then that really does, almost 100% of the time, mean that a chemical change or a chemical reaction has taken place. And then same thing with taste, okay? If something tastes different, then that is really good evidence that a chemical reaction has taken place. Great example of the smell and taste is milk, right? So if you take out milk out of your refrigerator, maybe you have a carton of milk that accidentally got stuck in the back and it's been in there, a week or two past its due date. If you open up that cap and you take a smell, it's going to smell different than it did when you first bought it, and that is because there has been a multitude of chemical reactions that have taken place in the milk, and so now it smells and definitely tastes different. One other piece of evidence, or two other pieces of evidence that you can use for a chemical change, if light or heat is emitted from whatever change is happening, that's pretty good, darn good evidence that it is a chemical change. I don't know if this is 100% of the time the rule, but in general, once again, in general, if light or heat is being given off, then it is more than likely, think like 95 to 99% of the time, a chemical change has taken place. And then lastly, if there is the formation of a solid precipitate or gas bubbles, okay, and I'm going to show you some videos during class when I see you next time. If there is the formation of a solid precipitate or gas bubbles, then that does mean that a chemical reaction has taken place. Okay, so that's it for the notes. There are some videos that we are actually going to watch together in class next time. If you want to watch them on your own time, that is totally a-okay with me, But we are going to watch all 4 of these videos in their entirety, and we're going to talk about them when we are in class next. So you don't have to watch the videos now, but you are free to if you so wish. Okay, that's it for the notes. I'm looking forward to seeing everybody in class next time. Have a great one.